So, good evening, everyone. Welcome back to the third live session of the Solar Energy Engineering and Technology. Myself, Soumya Tiwari. I am PhD scholar at Department of Sustainable Energy Engineering at Kanpur. So, we will start our session right now. So, is my screen visible and my voice audible? Okay, just write in the chat box. Okay. Okay, fine. So, let's start. So, in this third live session, we will discuss about week 3 content, for which assignment due date is, I think, the 14th August. So, we will see what are the content of this week 3, what are the question that are discussed already in the lecture. So, I will explain approach to that questions, and also later in the session, we'll also solve some numerical problem. Okay, so in the third week, what has been taught is the estimation of solar radiation under different climatic conditions. So there are a lot of empirical equation for predicting what is availability of solar radiation at a given position at a given time. So uh, basically, the measurement of solar radiation over a period of time is not possible. Like even some data are available, but these data may not be in the desirable form that are actually required to estimate, or that will be useful for application purpose. So for that, some empirical relation has been derived, that includes several meteorological parameter like sunshine hour, what is cloud cover, what is precipitation. So if we want to classify the weather to predict what is the solar radiation for different climatic or weather condition, then we can basically uh, characterize in two things. Okay, so a clear day and a cloudy day. So this is cloudy day. Okay, or clear day, your daily diffuse radiation to daily global radiation. So this factor ht by hg. So h, when notation h, when you'll see, so this, sorry, so h is for daily, if you remember the notation. um, um, and I is for hourly, right? So the daily, d is, the small d represent the diffuse, and this g represent the global. I'm just telling you to basically understand what the notation means. Okay, so this is daily diffuse radiation to daily global radiation. Okay, so if this parameter is less than equal to 0.25 and the sunshine hour is greater than 9 hours, so it is considered to be a clear sky. Now, if your this parameter sg by sg is between 0.25 to zero point 0.5 and the sunshine hour is 7, between 7 to 9 hours, then it's hazy day, or fully hazy day. If this parameter is between zero point 0.5 and 0.75 and the sunshine hour is between 5 to 7 hours, it is hazy and cloudy day, partially hazy and cloudy day. And if this parameter is greater than equal to 0.75 and sunshine hour is less than equal to 5 hours, then it is considered to be the fully cloudy day. Okay, so first we, if in question it is given for this day, this is the number of sunshine hour. So from there you can first, you have to understand whether it is talking about the clear day or whether it is talking about the cloudy day. So the empirical relation for clear day and cloudy days are different. So that we will see in the upcoming slide. So For if you're talking about the cloudy skies, okay, so there are some relationship that we need to, that has been derived, empirical relationship. So one is the monthly average daily global radiation. So monthly average daily global radiation, monthly average daily diffuse radiation, monthly average hourly global radiation, okay, and monthly average hourly diffuse radiation. So these are the parameter in which relation, empirical relationship has been established. Now so these are all the formulas, okay. So it will be probably given in the question, but you have to remember some of the, like this angstrom correlation. So it gives relationship between the monthly average daily global radiation to your monthly average uh, global radiation on a clear day. So on a clear day, so it will be same as the extraterrestrial, because we are talking about the cloudy days, okay. So we are assuming that whatever radiation is coming, it is the whole part of it is coming on the to the observer. So this hc bar, so c is for the clear day notation, and rest I have explained. So remember that here I have explained that H is for daily and I is for hourly. If we put a bar onto it, so it will be summation of all the days of in a month. So it will be your monthly average daily global radiation. So if you put a bar onto it, just to give you an idea how this notation are um, coming into picture, okay. So if we talk about monthly average daily diffuse radiation, so if we just talk about the daily diffuse radiation, it will be hd, and if we talk about a monthly average, then we will put a bar onto it. I hope these notations are clear, because it will be used again and again, and you have to at least know what notation we are talking about to basically put the parameter into equations and you get your answer. So this angstrom relation gives relationship between basically used to calculate the monthly average daily global radiation for a cloudy sky. So the relation is given as shown. So it is basically hg bar upon hc bar, which is equal to h naught bar equal to a plus b into s bar upon s max bar. Now what is this s? S is your sunshine hour, right? And it, if we put up s max, then it will s max bar, so it will be your total day length, right? So we are talking about what is the maximum sunshine hour in a particular day, so it's basically your day length, right? So hope these notations are clear. So how this um, parameters will be calculated. So basically s bar is your the sunshine hour for a particular day, that will be given in your question. Now the rest of this is the thing that we are going to calculate, hg bar. What is it? It is monthly average daily global radiation. Now what are the unknown parameter? Unknown parameter is s naught bar and s max bar, s max bar, okay. So this is the derivation that has been done into your class only, or your lecture also, but I will quickly explain this, so you basically develop understanding of how things are calculated, okay. So the extraterrestrial radiation, we know for extraterrestrial radiation we have already studied this formula. Extraterrestrial equal to isc, which is solar constant, into 1 plus 0.033 cos 365 into n, right? So on a horizontal surface, a cos theta z factor will be included, where cos theta, we know this long formula that we have studied way back into the previous lectures. So we are talking about horizontal surface, then beta will be 0, and theta will be equal to theta z, where theta z is your zenith angle, right? So we'll put all this parameter into the equation, and we will get a simplified version of this cos theta for a horizontal surface. We'll put back into the equation. So this will be your extraterrestrial radiation on a horizontal surface. This we are talking about uh, this unit will be kilowatt per meter square, right? So it will be kilowatt can be written as kilojoule per second, right? So basically, if you talk, this equation gives per second value of the global radiation we are uh, receiving, right? If we want to calculate hourly radiation, then we have to multiply it by 3600, because 1 hour contains 3600 seconds. And if you talk about, so its unit will be now kilojoule per meter square per hour. And if we'll talk about 1 day radiation, then we have to integrate it. Integrate omega is your hour angle, right? So we will integrate it with respect to time for a whole day, right? dt. So just you need to understand what unit or what parameter we are talking about. It If it's talking about in the if in question it is asking in kilowatt per meter square, so you will be using this formula. If it's talking about hourly, then you have to use this formula. um, Now, so this dt can be we know two relation, right? In 1 hour there is equivalent to 15 degree your hour angle. So from that, we'll get the dt in term of d omega. We'll solve this, and this is the final formula that we need to remember. Okay, this formula. So H naught equal to 3600 into solar constant into 24 by pi into 1 plus 0.033 cos 360 and upon 365 into omega s sin phi sin delta plus cos phi cos delta sin omega s. Now, if we, this is for daily, right? What we have for 1 day we have calculated. If we calculate it for a particular day of a month, that is considered as the average day for a particular month, that we have discussed in previous class also. So this can be represented for a whole month, right? So it will be h naught bar. So say for January, the average day is 17. So for, if we calculate it for 17, for n equal to 17, this represents the average daily global radiation we calculated for the whole month. I hope this is clear. So this is the important formula that you need to remember. And if you have and this is the formula. So we have calculated h naught. We'll put back into the equation. And s max bar, you know that it will be equal to 2 by 15 cos inverse 10 minus of tan phi into tan delta, that we have already studied in the previous class. Now, this, there are two constant also there, a and b, right? So these are already been estimated for different location in the India. So this table will be given in the question if any question comes based on this formula, angstrom formula. Okay, so you just need to see the what are the value of a and b and just put back into the equation. Now, uh, just to remember it once again, the representative day of a month for a solar radiation calculation is this. So for January it's 17 Jan, for Feb it's 16 Feb, and for March it's 16 March. So this thing, it will be easier for you to remember it. Okay, so this thing. Now, one another empirical relation that like so this relationship, we have seen that it's in term of, okay, um, uh, this a b it's in term of your sunshine hour. Okay, but Gopinathan was what did is he also included the factor like precipitation and some meteorological parameter, and then he basically he basically updated this formula and updated this a and b parameter to a1 and b1. And a1 and b1 was now, so what is the extra parameter that I think this will be minus and this will be plus. I don't know why it's the signs have okay. So and this will be, I think, plus, and this will be minus. Okay, so now he has excluded one extra parameter, which is EL, and EL is basically elevation of that place. Okay, so this is the basically improved formula than angstrom thing. Okay, so it's similar thing, similar parameter we have s bar, s max bar, s naught bar, and hg bar. Just the constant parameter has been improved. Now, sir has explained this question in the your lectures. We'll just see how the question has been approached. So the question was to estimate the monthly average daily global radiation. So what it's talking about is Hg bar, right? On a horizontal surface at Delhi, phi and latitude and longitude are given during the month of March. If the average sunshine hour per day is 7.5 hours. So what is already given in the question? Your phi is given, L is given, your month is given March, and your average sunshine hours per day. This is your S bar. Okay, this is already given in the question. What you need to calculate is Hg bar. So we know the formula Hg bar equal to. Okay, so uh, Putta has some question. You can unmute yourself and ask the your query.
Madam, actually, while I am solving assignment problems, similar kind of problem has given in assignment also,
Right.
but they have not mentioned sunshine hours. Here it is mentioned 7.5 hours, but
Okay.
in the assignment problem they have not mentioned sunshine hours. For such kind of questions, how can we measure yes? How can we measure yes?
Uh, I don't know. I
Sunshine
think
hours.
it will be. Just let me check. The sunshine hour you are talking about. So, this.
The question number is 4, ma'am. Question number is 4.
Okay, okay. Just a minute.
Question number 4. 4,
Question
ma'am.
number four. So this
Yes.
is at a location with latitude of 48 degree. The monthly average terrestrial radiation on horizontal surface. Okay, so monthly average terrestrial radiation on horizontal surface is given. The monthly average clearness index. Okay. Uh, so this is so I cannot mention in uh, like in detail, um, but I think it can be solved uh, without um, uh, without the requirement of this S bar parameter. So so I think you look back into the what formulas, what are the parameter required to calculate this particular value, and what is the parameters in that. Okay, so you will understand that what is the actual thing that is required to solve this question. Okay, look back into formula,
Okay.
look back into parameters, you will get your answer. So note that there are different empirical formula, right, and different
Okay.
param.
Okay. Okay.
So you look back. Uh, if you still have doubt, okay, then we can discuss it in the next class. Okay,
Okay, ma'am.
because I cannot tell you in detail right now. Uh, so Rushali is saying that my voice is not audible. So is it for everyone? My voice is audible or not? Is my voice audible? Can everyone write in the chat box yes or no? Okay, audible. uh, I don't know, Shali. It might be your network issue or something, because everyone else is saying that it's audible, right? So maybe you can join again and see that whether it is audible or not. Okay. Okay. So where were we? Okay. So this thing. So we were on this question, right? So so let's start. So phi is given 28 degree 38 minutes. So we can calculate back to in degree, right? 28.63 by dividing it 38 by 60. For March we have, if we look back for March, it is 16th March is your representative day. So we can calculate n equal to 31 plus 28 plus your 16th. So it will come to 75, right? So your n will be 75 for March month. So for based on n we can calculate the declination angle delta, and we know already know s bar. Now we have phi, we have delta, we have s bar. What we need to calculate is your s max bar, right? So it's a particular day length. Okay. So its formula we already know. This formula is 2 by 15 cos inverse minus tan phi into tan delta. We know the value of phi, we know the value of delta, we can calculate s max. And note that this value is the omega s. Okay. So omega is basically cos inverse minus tan phi tan delta. We can get in degree. Okay, pay very particular attention to the omega s, whether it is in degree or whether it is in radian. Where to use degree, where to use radian. Okay, so uh, now we can calculate. We have calculated s max bar. What else parameter we need is s naught bar. So formula that for that we already know s naught bar equal to 3600 into 24 by pi isc into your 1 plus 0.033 cos 360 by 365 into n. We will put n equal to 75. ISC we already know the value, so it's 1367 watt per meter square. Okay, so we need to put in kilowatt per meter square. So you have to pay attention to the units very carefully. Okay, because once you will in say in this step you make a mistake, then in every step that is mistake will be continued. So pay close attention to the units, every unit. Okay, so from there and this will be particularly this is cos theta value integrated over particular day, so it will be omega s sin phi sin delta plus cos phi cos delta sin omega s. So we can get s naught bar into kilojoule per meter per day, right? So we know the s naught bar, you know the s max bar, we know the s bar value, we know the a and b value. So a and b value for Delhi, we can look back into this table. So for New Delhi, A value is 0.25, B value is 0.57. We can put all this parameter into the question and we can get the HG bar value. So this is how has virtually, okay, let me just check 1 minute. Vishali, is my voice audible? I think you have joined now. Okay, if the problem persists, you can write in the chat box. Okay. So this is this question is basically gives understanding how to uh, basically identify what are the parameter given in the question and what we are going to use, what formula are required that you need to remember. Now we have already seen the monthly average daily global radiation. What other parameter we have to see is monthly average daily diffuse radiation, so which is SD bar, monthly average hourly global radiation. So so this will be Ig bar and this will be monthly average hourly diffuse radiation. So this is for cloudy sky. We are still talking about cloudy sky. And then we'll look for the clean sky or cloudless sky. What is the value of our global beam and diffuse radiation? So again, some empirical relations are given. So Liu and Jordan has given this relation, where you can see the SD bar is your monthly average daily diffuse radiation, and this is the your monthly average daily global radiation. So this parameter we have already seen how to calculate. So and this parameter also we already know. So these two parameters so SD bar can be calculated based on these two parameters that we have already seen how to calculate these two parameters, Hg bar and H naught bar. So after getting these two parameters, so there is basically clearness index factor. Okay, given by symbol is KT. Okay, so KT bar is basically Hg bar upon H naught bar. This is the factor uh, uh, in which so this SD bar is given in term of this function of the KT. Okay, so as you can see, this can be written as 1.390. So it will be, I think, minus, and this will be plus, and this will be plus. Okay, and Modi and Sukhatme has also given SD bar upon SD bar, this term in term of this will be, I think, minus KT parameter, and Gard and Gorga is also given. So I think this will be minus. So here you can see these two has given in term of your HG bar and H naught bar. Guard and Gorg has directly given in term of your sunshine hour. Okay, so these parameters will be like this equation will be mostly given in the question. If not, you need to remember. I think Modi and Sukhatme will are extensively used for Indian uh, climatic condition. Okay, so now if you talk about average hourly global radiation, monthly average hourly global radiation, then the formula for it is Ig bar upon Hg bar equal to I naught upon H naught, and I think this is A plus B cos, and here it is omega, right? Where A and B are given in term of basically some. This is omega s minus 60, and this is sine omega s minus 60. I think this is the formula. Okay, and monthly average hourly. So you can see that this parameter can be easily calculated if we know different angles. So if you know omega s, you can calculate A and B. If we know, we can we know H naught bar, we know Hg bar. We have already seen how to calculate like these two parameters. So Ig bar can be calculated. Monthly average. If you talk about monthly average hourly diffuse radiation, then this is a very simple formula given by Liu and Jordan, where SD bar, the monthly average hourly diffuse radiation upon your monthly average daily diffuse radiation equal to I naught bar upon H naught bar. So um, basically this formula uh, like you have to practice again and again. So this formula will be how to use this formula, how to remember this formula. That part will be easy for you. Okay, so this clearness index parameter in terrestrial region can be uh, uh, explained in term of hourly, daily, and monthly. So if we are talking about hourly, so it will be KT will be I upon I naught. Daily, then it will be H upon H naught, and if we're talking about monthly, then it will be H bar upon H naught bar, right? So you can see how this I hourly is represented by I, daily is by H, and if you talk about monthly, then it will be H bar, right? Now for a cloudless sky, so we are talking about clear sky. So for that we know that Ig equal to Ib plus Id. This we have already seen. So the global radiation equal to sum of the direct or beam radiation and plus your diffuse radiation. Now IB can be given by So this is your normal beam radiation into cos theta z. So if this is your tilted surface, this is your solar radiation coming, we are talking about direct radiation. Okay, so this will be IB will be your IB and cos theta z. This we have already discussed, right? So and now so I think um, okay, so IB and cos, so some parameters are here and there, so I don't know. Okay, so basically IG can be written as IBN, so we will replace IB by IBN cos theta z plus ID. So this is the formula that you need to remember. Okay, now how to calculate this IBN and ID? So Ashare model has postulated that this IBN can be expressed. These all are empirical relation. Okay, so there are some reasoning behind deriving this formula. You just need to focus on what formulas are given. So you have to remember this formula. So a into e to power this is I think minus b cos theta z, minus b by cos theta z, or as far as I remember. Okay, and ID will be your C into IPN, where this A, B, and C are the constant whose value has been determined on monthly wise basis. So we have whole formula for each month A, B, and C value. So this is suggested by Iqbal, and it's used for predicting your hourly solar radiation on a clear days. Now let's see how this all formula is applied into a question. So this was the question discussed in the class. So the question was estimate the hourly global beam and diffused radiation at Guwahati, whose latitude and longitude was given between 10 to 2 hours 14 hours on May 15, 2019, and compare this data with the measured value given in the following table. So the what things are given in the question. So your phi is given, which is 26 degree 9 minute. Okay, and your latitude is given, your hourly global radiation and diffused radiation are also given. Okay, so between 10 to 14 for each hour, this global radiation, diffused radiation. So basically what we can measure at a given location. Okay, so that parameter has been given in the table. So we have phi equal to we can calculate in degree, right? And uh, okay, so um, n can be calculated for May 15, and based on n, which comes to be 135, we can calculate the declination angle. So we have phi, we have delta. What else can be extracted from this question is your omega. So for 10 to 11, so for 10 to 11, so let me explain it like this. So okay, fine. So for 10 to 11, we know for each hour is equivalent to 15 degree, right? So if we're talking about 12 noon, solar noon, okay. So for each hour, so say 11, and it will be 1, so say 13. Okay, so each hour is equivalent to 15 degree. So if you're talking about 10 to 11, so it will be how much omega will be. So 10 to 11 will take its average value, so we'll consider 1030. Okay, for 10 to 11 we'll consider 1030, for 11 to 12 we'll consider 1130 average of. So and because this omega can be calculated at particular hour angle, it's not for a range of hour angle. Okay, so that too you can do if you integrate it from the basic equation. So then you have to derive it all the way to h naught, right? So for simplicity what we do is we take an average value between 10 to 11. So for 10 to 11, we say 10:30, 11 to 12, 11:30, and similarly 12:30 and 13:30. So for that we can calculate hour angle as this is your solar noon. 12 o'clock solar noon. So for till 11 it will be 15 degree, equivalent to 15 degree. And for 10:30 it will be half of 15 degrees, so it will be 7.5, right? So 15 plus 7.5, it will be 22.5 for 10 to 11. For 11 to 12, again, it will be 11:30, which will be equal to 15 divided by 2 equal to 7.5. So these are the positive value because it's forenoon, and afternoon will be in negative, right? So similarly, it will be minus 7.5 and it will be minus 22.5. Hope this thing is clear how to calculate omega for a, if the question is given for a particular hour, like a particular duration of the time. Now we have extracted all the parameters given in the uh, question. Now we have to focus what is the hourly global beam and diffuse radiation. So we know that cos theta, we first have to calculate, we know the cos theta z parameter will be used in the question. So cos theta z can be calculated in term of declination angle, your latitude and your hour angle. So this, if you put back into the equation all the given values, then cos theta at different hour angle 7.5, 22.5, minus 7.5 and 22 minus 22.5 can be calculated. So uh, and now you can put back into the equation, so it will be IBN is given in the question. Sorry, yeah, if you remember the formula, IBN equal to a e to power minus b cos theta z. Okay, so we know the value of cos theta z. We know we have to see the parameter a and b value. Okay, so the location is Guwahati, right? So though, so and your day is your May 15. Okay, so May 15 will lie between April and May, April 21 and May 21. So we will basically interpolate this value. So basically for May 15, if you want to interpolate the value of A, then it will be your April 21 value minus what is so this is for 30 days. So from April 21 to May 21 it is 30 days. So we'll calculate for one day, so it will be 1130 minus 1106 by 30. And from April 21 to May 51 it is 24 days, so we will multiply it by
अरे
24 days.
ले ले यार जल्दी
Okay, I will
ठंडी हो गई क्या पी लेगा क्या ठंडी हो?
okay, I'll request you
देख
all to mute yourself.
पी ले मेरे को बता
I
दी
think Mohan, your mic is on, can you please mute it?
ठीक है
Hello.
बिस्किट ले रहा है क्या
Hello, Mohan. Okay, thank you. So similarly, so you'll get the value of S. Similarly, you can interpolate value for B and C. Okay, you can put all back into the equation. We can calculate the value of A, B, and now for each omega, basically value of omega, we can calculate IBN. Okay, for each hour, right? And ID we know C into IBN. We know the parameter C, value of this, and IBN we already know. We can calculate ID. So basically your IG will be IB plus IDW. So this is, so you can calculate beam, we can calculate the diffuse, and you can calculate beam plus diffuse equal to your global. So this table is basically your uh, uh, measured thing and your predicted thing. So just to compare what we have, what has been actually measured and what is being predicted, whether it's similar or not. So we can see that this is for 10 to 11 hours, these value is over predicted. So from calculation we are getting value greater than what is actual measured at that location. So just to understand that, that is why we need different empirical formulas for different location, for different meteorological condition, right? So it's not like one formula is valid for all the location on the earth, because the and atmosphere, different atmospheric condition is different at different location, right? So that's why we need different empirical formulas. Now we have seen till now the all the solar radiation on horizontal surface for cloudless sky and your cloudy sky. Now if we talk about on tilted surface, Now your surface is not horizontal, it's tilted. So what will be value of flux on this tilted surface? So if you remember the first class, we have studied three type of radiation: beam radiation, diffuse radiation, and reflected radiation. Now the extra added parameter is this reflected radiation that will come on this tilted surface. So for that, uh, tilt factor is determined for each part of this whole global radiation beam and diffused and your reflected radiation. What is tilt factor? Tilt factor is basically ratio of your beam radiation falling on a tilted surface to falling on your horizontal surface. So this is your basic understanding of this tilt factor. So tilt factor is basically what is falling on a tilted surface to what falling on the horizontal surface. That parameter we will include in the your original equation to get the value of your solar flux on tilted surface. So if we'll see IB upon IB dash, so we know that it will be IBN cos theta upon IBN upon cos theta z. Theta z is your zenith angle, that will be equal to, so your incident angle will be equal to your zenith angle for horizontal surface, right? So it will come IB equal to cos theta upon cos theta z. And we know all the long equation, so it will be sine delta into, if we for tilted surface it will be, so it will be, if we see for horizontal surface it will be sine delta, this will be sine delta sine phi plus cos delta cos phi, and it will be cos omega, right? So for a tilted surface it will just be phi minus beta, where beta is your tilt angle, and it will be plus cos delta cos omega, and it will be your cos phi minus beta, if you remember the formula. So this will be your beam radiation tilt factor. Similarly for diffuse radiation, uh, the value that has been the equation that has been derived is RD will be, so D is for diffuse, B is for the beam, R is represented for your tilt factor. Okay, it will be 1 minus it will be 1 plus cos beta by 2. I think this will be 1 plus cos beta by 2. And for reflected part, your tilt factor will be 1 minus cos beta by 2, and multiplied by your reflectivity. This reflectivity is basically reflectivity of the surface from which your beam is reflected. Okay, so if your surface is ground, then this rho value is 0.2. Okay, so your solar flux onto a tilted surface, okay, that will be equal to your the beam radiation into this tilt factor for beam radiation plus diffuse radiation into tilt factor of this diffuse radiation plus your um, tilt factor for reflected radiation into your IB plus ID, which is basically beam plus diffuse, that will be equal to your global radiation. So this formula you need to remember, this tilt factor formula you need to remember. So basically this, now this formula has been basically manipulated to get in term of ratios, known ratios. So basically they have divided this formula by Ig is your global radiation beam plus diffuse. So we can basically shuffle it all, and what formula we will get is this formula. So for IT bar tilt surface, so monthly average of hourly radiation on tilt surface upon global monthly average global radiation, uh, hourly radiation global hourly radiation will be equal to 1 minus ID bar upon IG bar into RB bar plus ID bar upon IG bar into RD bar plus RR bar. Okay, this equation is important, where RB bar is for representative day of the month, so that's why we are talking about the monthly average. Okay, and similarly if we'll integrate it for particular day, then we can get global uh, daily basically daily radiation, right? So these RB bar will be, this RB bar will be integrated over this will be integrated over time, right? So this will be integrated over time. So for that, if we'll integrate it, RB bar value will be similar to this equation that we have got. And note that the RD and RR are independent of your omega. So these two equation will be same. So we'll put back into the equation. Now this is basically denoted by capital R if we're talking about daily radiation. Okay, and this is your formula. I hope all the notations are clear. How this notation are coming, how these formulas are coming, what are the important formula that you need to remember. Now this is the question. So calculate the monthly average hourly radiation falling on a flat plate collector facing south with a slope of 26 degree. Given the following data, the location is New Delhi, for which your latitude and longitude angle are given. Your month is given, your time is given 11 to 12 hours, and your ground reflectivity is given zero point 0.2. Other than that, what is given is your Ig bar. So your hourly monthly average hourly global radiation is given, and monthly average hourly diffuse radiation is given. Okay, these two parameters has been also given in the question. So let's quickly write down what is given in the question. So your tilt angle slope is given 26 degrees, so beta will be your 26 degree, right? Phi is given, phi is 28 degree 23 minutes. So phi is given, so we can calculate in degree, it will be 23 by 60, so that you can calculate. Your month is given for, so for a particular month the representative day for October will be 15th October. So for that you can calculate the n value. So for Jan 31, Feb 28, March 31, similarly the value n will be 288. You can put back into the declination angle formula, we can calculate declination angle. So what we have is declination angle, your phi, your omega can also be calculated. So it's for 11 to 12. So if this is your solar noon, so this is 11, right? So from 11 to 12, the average value what we are taking is 1130, right? And this will be half of 15 degree, which will be equal to 7.5 degree. So it's in forenoon, so this will be positive, and afternoon are negative. So these are all the parameters. Now we can quickly calculate the tilt factor for beam radiation. The formula we already know in term of declination angle, latitude angle, tilt angle, and your hour angle. So we can put all this parameter into the equation. We can calculate the RB value. Since it's been calculated for representative day, then it can be also written as RB bar, right? Similarly, we can calculate RD and RR, and Ig bar value is already given in the question. Okay, so monthly average, your hourly global radiation is also given in the question, and ID bar is also given in the question. So we can put all this value back into this equation, and we can get your IT bar value. So hope this is clear how the question are solved. So similar numerical will problem is given in your assignment also, and similar problem will come into your final exam also. So you need to practice this, basically these questions to get quicker in getting your answers. Okay. So now we'll start with uh, our question series. Till now, does anyone have any problem in any part of any questions or any conceptual part? You can write in the chat section if you have any problem till now. Is it clear? No doubt. Okay. So let's move to our question series. Okay. So This is the first question for you. The total radiation incident on an inclined surface consists of following components. So, beam radiation, diffuse radiation, or radiation reflected from ground and surrounding. Select the correct answer using the code given below. I request everyone to write their answers in chat box. I'll repeat the question. So the total radiation incident on an inclined surface consists of following component: beam radiation, diffuse radiation, radiation reflected from ground and surrounding. Select the correct answer using the code given below. Is it 1 or 1 and 2 only, 1, 2, 3, or 2 and 3 only? Okay, I'm getting answer. Ushali has opted for option C. Shang option B. Karan also opted for option C. Anybody else? Okay, let's discuss this question. So it's very basic question. We are talking about total radiation. Total radiation that has been incident on an inclined surface. Okay. So inclined surface, so we are not talking about horizontal surface. We are talking about inclined surface. So for inclined surface, the total radiation is sum of your beam radiation, your diffuse radiation coming from different direction, as well as your radiation that has been reflected from ground and from any, say, some object is there. So if it is reflected from some object onto your tilted surface. So the correct answer for this question is option C, which is 1, 2 and 3. If it, so the correct answer is option C. If it would have been horizontal surface, okay, then it would have been beam plus diffuse. Okay, so option B would be correct. I hope this is clear. Okay. Now, the next question is a numerical problem. Calculate RB for a surface at a latitude 40° north at a tilt 30° toward the south for the hour 9 to 10 solar time on February 16th. So you can look back into the formula that has been given in the lecture. and you can try to solve this numerical problem. So for those people who doesn't remember the formula, I will simplify it further. I'll write down the formula. Just you have to put the values into the equation and get an answer for it. Okay. So the formula is, we are talking about RB. So RB is equal to, so RB. The formula is omega st. This is sine phi, sin, so RB will be equal to omega st sine phi, sine phi minus beta, plus cos delta sine omega st into cos phi minus beta, divided by your omega s sine phi sine delta plus cos phi cos delta into cos your sine omega s. So this will be, cos delta cos phi, and this will be sine omega s. Okay, so this is the formula. So see what parameters are given in the question, what needs to be calculated to finally get this RB value. So I'll give a few minutes to solve this question. Okay, does anybody has got this answer? Okay, let me simplify this question for you further. So you just need to calculate. Okay, 2 minutes, Rishali. Okay, fine. Okay. Uh, any answers? Okay, 1.66. Okay, let's solve this question. So what's given in the question is latitude angle is given, phi is given, 40 degree. Tilt angle is given, beta is given, 30 degree. And toward the south, so your azimuth angle is 0 degree. And for an hour is given 9 to 10 solar time. So what is given is, if it is 12 or noon, this is 11, and this is your 10, and this is your 9. Okay, so between 9 and 10 it will be 9:30, right? So it will be 15 degree plus 15 degree plus your 7.5, right? So omega will be your 15 degree plus 15 degree plus your 7.5, which will be equal to 37.5, right? Day is given February 16, so n will be 31 plus 16, so which will be equal to your 47. So based on that, you can calculate the declination angle, which will be 23.45 sine 360 by 365 284 plus n. Okay, you can calculate the declination angle. Now, if we look into the formula, RB equal to omega ht sine phi sine phi minus beta plus cos delta sine omega st, and this is into cos phi minus beta upon omega s sine phi sine delta plus cos phi cos delta into sine omega s. So we know the omega, we know phi, we know beta, we know delta. What will be omega and omega s, right? Omega we know already. So this is for a particular uh, uh, 9 to 10 solar time, right? Omega s is for the horizontal surface and omega st is for the tilted surface. So uh, for a whole solar day, what will be omega s? It will be cos inverse minus tan phi into tan delta, right? And omega st will be cos inverse minus tan this will be phi minus beta for tilt surface we are talking about into tan delta. So we can put phi and delta and beta into the equation, and we can get omega s and omega st. We know phi, beta, omega st, delta, and all the parameters. So if we'll put back into the equation, we can get the value of RB. Okay. So if this approach is similar, I have to solve this question also. So if this approach is similar, then your I think Rushali, have you followed the same approach? You can unmute yourself and tell me like, have you followed the similar approach, or have you followed any another like process?
Followed the same approach, just omega st was wrong.
Okay, so note that the RB is basically what is we are receiving on the tilted surface to what is receiving on the horizontal surface. So omega st beta parameter will be included. So I hope this thing is clear now. Okay,
Yes, ma'am. Yes, thank you.
so note that if we instead of RB we are talking about a smaller RB. Okay, so just for this particular 9 to 10 solar time, then what changes will be there? So basically RB will be your cos theta upon cos theta z, theta z, that will be again your sine delta. We are talking about tilted surface, so it will be phi minus beta plus your cos delta cos omega, and it will be this will be phi minus beta, right? We are talking about tilted surface, and again for horizontal it will be simply sine phi sine delta plus cos phi cos delta and cos omega. So here your omega will be this 37.5 degree that we have calculated. Okay, so we can calculate, so this declination angle will come around minus 13 degree. Okay, and so your parameter will be 1.61. Your answer will be RB value will be your, so this is small RB. Okay, 1.61. So this is similar to what you have got, I think. But now you can understand where to use omega, where to use omega s, how to where to use how to calculate omega st. So these are similar parameters, but their application are different. Okay, so hope this clear is this question is clear to you all. Any doubt in this question? Okay, so I think this question is uh, clear. Now moving on to the next question. So I'll read out question to you. So during the month of October at 11 to 12 hours, okay, solar radiation incident was observed at Chennai on a flat plate collector facing south. Okay, we are talking about flat plate collector facing south with a slope of 15 degree. Consider the mean global radiation and mean diffuse radiation. So what's given in the question is mean global radiation and mean diffuse radiation incident on the inclined surface, uh, which is given in kilojoule per meter square per hour, and respectively. Assume the ground reflectivity to be zero point 0.2 and the representative day is given already in the question, 15th October for October month. Now you have to calculate the tilt factor for beam, diffuse and reflected radiation. So I will request you all to solve this question and write your answer in the chat box. I'll give few minutes to you. Is everyone solving the question? Should I write formulas for each one? Or okay, I'll write the formulas to make it more easier. So, so basically, it's has anybody got any answers till now? Even for the eighth question? Okay, okay. Okay, anybody has got any answer? Vishali? Maybe the first part, or the second, or the third. Any answers? Okay, so you can also tell. It should not it isn't. So it should not be the exact to the 4 decimal point. So if we get similar to whatever option you see, you can tell me that option also. So sometimes there is some calculation glitches here and there. Okay, 8th B, and so you're getting 8th B, ninth. Anybody? Any answers? Okay, let's see what's given in the question. Okay, so during the month of October at 11 to 12 hours. So we are talking about Chennai. So phi is given, right? Your phi is 13° north. Your hour angle is given. So hour angle will be your from 11 to 12. It will be corresponding to 11:30, right? So which will be equal to your positive 7.5°. Your gamma is given 0. Your slope tilt angle is given 15°. Okay. What else is given? Mean global radiation and mean diffuse radiation. So what is given in the question is your mean global radiation, which is given 2408 joule per meter square per hour, and your diffuse mean global diffuse radiation is given 1073 kilojoule per meter square per hour. Ground reflectivity is given, so rho is given zero point 0.2, and n is given. N is for 15th October. Okay, so that you can calculate by adding from 31 for Jan, 28 for Feb, and similarly. So this will be I think, and will be 288. Okay, and will be 288, and declination angle you can calculate based on this n value, which will be 23.45. This will be sine 360 by 365 284 plus n, right? So this will be declination angle. It will come around minus 9.599 degrees. Okay, now coming to RB. So RB is formula, if you remember, it is cos theta by cos theta z. So cos theta on the tilted surface will be this will be sine delta sine phi minus beta plus cos delta cos omega, and this will be cos phi minus beta. And so on horizontal surface, it cos theta value will be sine delta sine phi plus cos phi cos delta and cos omega. So we know the value of delta, we know the value of phi, right? We know the value of beta, we know the value of omega. We can put back into this equation, and we can get the value of RB. So the correct option is value, that RB value you will get is 1.1854. Okay, option C. Oh, sorry. So this will be option A. So, so the correct value will be 0.9830, which is similar to 0.9385. Okay. So sometimes when we solve the question, so the exact value maybe to the 4th decimal point, it will not be exact. So you have to see what is the next similar answer, right? For diffuse radiation, if you talk about, then the formula for this is 1 minus cos, 1 plus cos beta by 2. We know the beta value, we can put back into the equation. The answer will be around 1.1200. So this option will be correct. And for reflected, it will be 1 minus cos beta by 2 into your rho. So this will be 0.0034. So option A will be. I hope this question is clear. Any doubt in this question? Is this question clear? Okay. Now, if in the same question, uh, monthly average hourly radiation has been asked. So, say on a tilted surface, monthly average hourly radiation has been asked. So, how would I have calculated this? So, I'll just explain it. Okay. So, after calculating all the tilt factor, you know the uh, drill, you know the formula. So this is the formula for calculating the monthly average hourly radiation in term of monthly average, like global radiation. This will be 1 minus id bar, this is given in the question, upon ig bar. Okay, into your beam radiation tilt factor plus id bar upon ig bar into diffused radiation tilt factor plus your RR bar. Okay, so you have already calculated these three values. IG bar and ID bar is already given in the question, right? So this has been already given in the question. You can put back into this all values into this whole equation, and you can calculate the IT bar. Okay, so let's move on to the next question. Okay, so this is the next question. So I'll read out the question to you. Estimate the monthly average daily global radiation or global horizontal irradiance at Vadodara during the month of March if the average sunshine hour per day is 9.5. Has anyone got any answers? Okay, since we have few minutes left, I will quickly explain this question. If anyone is trying to solve this question, they can look back into what is the approach they are following is similar to the explained here. Okay, so what has been asked in the question is estimate the monthly average daily global horizontal irradiance at Vadodara. Phi is given your 22° north during the month of March if the average sunshine hour per day is 9.5. So your average sunshine hour is given 9.5. This is in hours, right? Now for March of month, your for month representative day for March is your March 16th, for which n will be 31 plus 28 plus 16, which will come around, this will be 75, right? So you can calculate the declination angle. So declination angle will be your 23.45 sine 360 by 365 to 84 plus n. This declination angle will be equal to minus 2.42. Okay, now what else we need is we need your day length, right? So we need your day length, which will be your 2 by 15 into your omega s, which will be cos inverse minus of tan phi, into your tan delta, right? We know the value of phi, we know the value of delta, we can put back into this equation. This day length will be your 11.87 hours. Now we know the relation, angstrom relation, right? So angstrom relation, uh, we have first, so it's talking about monthly average daily global horizontal irradiance. So for that, one more parameter is needed, which will be h naught bar. Okay, so your monthly average daily extraterrestrial radiation, or similar to your clear sky day. So this formula is, if you remember the formula, it is 3600 into your solar constant into your 24 by pi, um, and this will be 1 plus 0.033. So this is extraterrestrial value ISC into your 1 plus 0.033 cos 360 by 365 into n, and then we have integrated it for the whole day. So those cos theta value has been integrated for the whole day, and now the parameter is your omega s sine phi, sine delta plus cos phi cos delta into sine omega s. So sine will be integrated to, cos will be integrated to sine. Okay, so you know the value of ISC, it will be 1.367 kilowatt per meter square, right? We know the value of n, which is 75. We know the phi, we know the delta, we know the omega s value. Omega s is basically this value. right? This is your omega s. Cos inverse minus tan phi into tan delta. Note that while solving this question, what is the unit of omega s and the omega s value that we put into sine omega s. So here this omega s will be in radian. Okay, and but if you put into this sine term, it should be in degree. So I'm telling where people usually make mistakes. Okay, so they usually put omega value in degree here also. So it should be in your radian, right? So if we solve this, it will be around. It will be 34206 kilojoule per meter square per day. Now you know the angstrom relation, which is hg bar upon h naught bar. So it's g equal to a plus b s bar upon s max bar. Now we know the s bar value, we know the s max bar value, we know the h naught value. So h naught bar value, right? What we don't know is the value of this a and b. So for that, we'll go back to the table. So if you look into the table, so this is the different a and b value for different cities in the India. So Vadodara is not given directly, right? If you'll see. So the closest to Vadodara is your Ahmedabad, right? So it has similar climatic condition. So if it's not given in directly uh, in this table, you can see what are the cities located nearby to it with similar geographical condition. So from here, the value of A will be 0.28 and the value of B will be 0.48. So uh, so we know the value of A. I think it was 0.28 and 0.48. Okay. So we can put back into the equation and your Hg var value will come to be 22718 kilojoule per meter square per day. This will be your final answer. So I hope this question is clear. Um, so I have explained how to approach the question, what are the important formulas that you need to remember, what are the tricks, where to use radian, where to use degree. If not directly given in the question, the exact location, we should look out for the location which is near to it with the similar geographical condition. Okay, so these are the key takeaway from this question. I hope this question is clear to you. Any doubt in this question? Okay, so I have few more question left, um, but we don't have any time left for this session. Should I continue it for next 5-7 minutes? I'll quickly explain the answer to this question. I will not give you time to solve this question as we are already beyond our given time. Okay, is it fine with everyone? Okay, Mohan has raised his hand. Yes, Mohan.
Yes, ma'am. Yes, ma'am. Yes, ma'am. You can will continue.
Okay, thank you. So now we have seen the use of angstrom empirical relation. What if in the question if I ask to use the Gopinath correlation, okay, to calculate the G bar value for Vadodara for the month of March. So the same question using different empirical formula. Uh, so in the question, the elevation is already given in the question, right? So if you if you remember the Gopinath formula, so it was Hg bar upon your H naught bar is given in term of improved A1 plus B1, and this will be same S bar upon S max bar. Now this A and B was A and B. Okay, so A was given as A1. Sorry, A1 was given as minus 0.309 plus 0.539 cos phi, and this was elevation angle. Elevation was included into this parameter EL plus 0.290 S bar by S max bar, and B1 is your 1.527 plus sorry, this will be minus 1.027 cos phi plus 0.092 EL, your elevation, minus 0.359 your S bar by S max bar. So you know these two value, S bar upon S max bar, right? You know the phi. Now in question, elevation angle is also given. So you can calculate the value of A1 and B1, right? So A1 will come around 0.421, and B1 will come around 0.291. Okay, so you can put back into the equation, then your Hg bar that you will get is 22367 kilojoule per meter square per day. So if we'll compare these two values, so it is, the first we got was 22718, and from this equation we are getting 22367. So it's not exact, but we get similar result from both these two equation, two empirical formula. So I've included this screenshot, so if my handwriting is not clear to everyone, so you have clear solution, so you can refer back it later, right? So this is for the same location. What will be the monthly average daily diffused radiation on horizontal surface? So for diffused radiation, if you remember, you have three formulas, right? So for diffused radiation, so let's quickly go back to the solution. So we know the Hg bar value, you know the H naught bar value, that we have already calculated. Now KT bar is basically your KT is your basically Hg bar upon H naught bar, clearness index. So you can basically get the KT value as 0.6642. You know the S bar value 9.5 hour, and S max we have already calculated 11.87 hours. Now this can be calculated from basically three correlation that we know. Okay, so your SD bar will be, this is I think this is Liu and Jordan, and empirical correlation, and this is more I think 1.4. So this is your Modi and Sukhatme, and this is your God and Garg. This correlation is God and Garg correlation. Just to show you how these three relation are actually applied in the real condition. So you can see that the value you got from the SD bar value you got from Modi and Sukhatme and God and Garg correlation are somewhat similar. So uh, this value is like and it only differ by 2.2%. But if you talk about Liu and Jordan correlation, then it is 18% less than the prediction made by your Modi and Sukhatme, and 16% less than predicted by your Gordon Girl. So basically, this the most appropriate. Basically, this Liu and Jordan correlation was given for 36 degree north and south for that latitude belt. So this is not generally applicable in Indian subcontinent, okay, or for India. So this, for Indian context, we will not use this equation. We'll preferably use this Modi and Sukhatme and God and Girl. So most of the time this Modi and Sukhatme, uh, um, this empirical relation is used for Indian region, that you need to remember, and that will be used most widely. And so just to this question was just to show what is the actual application, how this empirical long empirical relation are actually applied to real condition. Okay, so hope this question is clear. Any doubt in this, all these questions? Okay, so I think Mohan has raised his hand. Any doubt, Mohan? You can unmute yourself
No,
and
ma'am.
okay, okay, fine.
No,
So
ma'am.
that's all for the today's session. Any doubt in any question, any part? Okay, if that's so, then I hope this session was useful to you all. If you have any question, you can come back in the next session, ask to me, or raise your doubt on the portal, as you all know. So I hope this session was useful to all. Thank you all for listening. I will now end the session. Thank you.